Okay, and we're back. So hopefully these problems went pretty well. I think they're pretty straightforward and simple. We have already talked about that if we have an isosceles triangle, which means a triangle with two congruent sides, then it must have two congruent angles. The angle that's made up of where the two sides come together is called the vertex angle, and the other two angles are called base angles. The base angles are the ones that are congruent. So in this first situation right here, let's take a look at this. We would see that this right here up top is the vertex angle. And these two right down here and here are the base angles, okay? And so those would be the congruent angles. So if this one over here is 28, then the other one over here would also have to be 28. And it says find the value of x. So what I would do is I'd say, well, I know that 5x plus 9 plus 28 plus 28 has all got to add up to be 180 degrees. So therefore, 5x, 9 and 28 would be 37. Add another 8, and I'd be up to 45, and 20 more would be 65. So 5x plus 65 is 180. Subtract the 65 from both sides, you get 5x is equal to 115, and if you divide by 5, then x has to be 23. So for that first one, for part A, x is 23. Hopefully that's what you got. On the second one, you look at this and you go, okay, well, wait a minute. You might kind of freak out because you might think that you're missing an angle up top here. But that's okay because we have the two base angles. So we know that this angle is congruent to this angle. This one is the same size as this one. So what can we do? We just set them equal to each other. We can say that negative 4x plus 9 is equal to 8x minus 3. And we got to move all the x's to one side or the other. So the easiest thing to do is to add 4x to both sides. We get 9 is equal to 12x minus 3. Add 3 to both sides, and we get 12 is equal to 12x. When we divide both sides by that 12, that makes it pretty easy. We get x is 1. Okay, so this one was real simple. X is 1. All right, now, hopefully you've got those, so now let's move on. I got great news. This is a two-way street. It's true forward and it's true backward. A minute ago, we had said if you have two congruent sides, then you must have two congruent angles. The other end of this is true. You can go backwards and this is still true. So that would be if you have something like this, a triangle with two congruent angles, then you must have something like this, a triangle with two congruent sides. And so what I'd like you to do is I want you to write down this basic conditional right now. If, and you can draw a little triangle symbol. I'll try to do it a little bit better than that one. That was pretty bad. If you have a triangle with two congruent angles, then you have a triangle with two congruent sides. Okay? Before we said if you had two congruent sides, you must have two congruent angles. Now you know if you get two congruent angles, then you must have two congruent sides. And so from that, we can look and try to do a problem like this. Hang on, this one got moved. Let's move it back to where it goes. Okay, right there. Okay, so now this says, what are the lengths of all three sides of the triangle? Now you look at this triangle, and the thing that should stand out is that we have two congruent angles. So if we have two congruent angles, then the sides opposite of those angles, hang on, this is moving. Then the sides opposite of those angles, there and there, must be congruent. This side is congruent to this side. It's always the sides opposite of the angles and the angles opposite of the sides. And it says, what are the lengths of all three sides? Well, this seems like a hard problem at first. But what I can do is I can say, well, wait a minute. I know that x plus 20 has got to be equal to 8x over 3. Because those two sides have to be congruent. Okay, to simplify this, I'd get rid of the fraction. I'm going to multiply everything over here by 3 and multiply everything over here by 3. These 3's would cancel out. And on this other side, I have to distribute, and I get 3x plus 60 is equal to 8x. At this point, I want to move all the x's to one side or the other. So I'm going to subtract 3x from both sides. And when I do that, I get 60 is equal to 5x. And at this point, I can divide both sides. If I say 5x is equal to 60, divide both sides by 5, and sure enough, x is equal to 12. Now, but let's make sure we understand the question. It said, what are the lengths of all the sides? It didn't ask what x was. We just had to figure out x to do that. So then we can go back in and plug in x. So if I take x and plug it in right here, what's x plus 20? Well, that would be 32. And that would mean that this side over here has to be 32 as well. Now, but I shouldn't just take that for granted. I should always double check. And so if I plug it in right here and said 8 times 12, all divided by 3. Well, 8 times 12 is 96, and 96 divided by 3 is 32. So we get the same answer. And then we take the 12 and we put it up here. And we get 6 times 12 minus 12. Well, 6 times 12 is 72, minus 12 is 60. So this side up here would be 60. So what are the lengths of all three sides of the triangle? Well, the two congruent sides are 32. Whoa, didn't mean to do that. The two congruent sides are 32 and 32. And the base, or the one side that's not congruent to the other two, is 60. All right, so now it's your turn. I want you to try the same kind of problem right here. Now make sure you understand you got to answer both parts. You got to find the value of x, and also you have to find the length of all three sides of the triangle. Okay, so we're going to give you a break for just a second. You're going to try this, and we'll come back together in about 5 minutes to see if you got it right.